Hi guys, this is O-level chemistry paper 12, June 2017, question 11. Dilute sulfuric acid is electrolyzed between inert electrodes. Which statements are correct? Hydrogen is released at the negative electrode. Negative electrode here refers to the cathode, and the reaction that takes place at the cathode is 2 moles of H positive ions accepting 2 moles of electrons, producing 1 mole of hydrogen gas. So this statement is correct. The second statement, oxygen is released at the positive electrode. Positive electrode is the anode, where 2 moles of oxide ions release 4 moles of electrons, producing 1 mole of oxygen gas. So this statement is also correct. 3. Sulfur dioxide is released at the positive electrode. It is not even produced. And 4, the acid becomes more concentrated. Yes, this is true, because when water is electrolyzed and hydrogen and oxygen gases are removed, the quantity of water in solution decreases and the concentration of acid, because water is removed, increases. So the acid becomes more concentrated. It is correct. Since statements 1, 2, and 4 are correct, option A is the correct option for this question. Question 12. Caesium is in the same group of the periodic table as sodium. Which products are obtained from the electrolysis of concentrated aqueous cesium chloride? So, cesium chloride is CsCl. And when this is electrolyzed and it's a concentrated solution, we will have production of hydrogen gas at the cathode, and we will have production of chlorine gas at the anode. So the question asks us product at the negative electrode. Negative electrode is the cathode. Cathode will have hydrogen produced, eliminating options A and B. Now, the solution that remains. Now, since hydrogen is removed from water, OH negative ions remain, and chlorine is removed from CsCl, so Cs positive ions remain. So Cs positive and OH negative together will form cesium hydroxide and not hydrochloric acid. Therefore, the correct option for this question is option C. Question 13. The diagram shows the apparatus for the electrolysis of aqueous copper 2 sulfate. In experiment X, both electrodes are inert. In experiment Y, both electrodes are made of copper. On which electrode is solid metal deposited? So since it is the electrolysis of aqueous copper to sulfate, copper is less reactive than hydrogen, so copper will be discharged in preference to hydrogen, and it will be discharged at the anode because copper ions will accept electrons and will be reduced to copper metal. So in experiment X, it would be deposited at the anode, so at the cathode. It will be deposited at the cathode. So copper will be there at electrode 2 because the negative terminal is where the cathode is. And the same thing with experiment Y. Electrode 4 will have copper being deposited on it because that is the cathode and that is where Cu2 positive ions will be reduced. Therefore, the correct option for this question is option C. Question 14. The energy profile diagram for the forward direction of a reversible reaction is shown. Okay, so the forward reaction is endothermic. For the reverse reaction, which row correctly shows the sign of the activation energy and the type of enthalpy change? So since the forward reaction is endothermic, the backward reaction would be exothermic. So options B and D both have exothermic present. So this eliminates options A and C. Now, as for the activation energy is the minimum energy required for a reaction to take place. Since activation energy is the minimum energy required, it will always be positive. Activation energy will never be negative because it is never the energy given off. It is always the energy required. So in option B, the sign of activation energy is negative, which is incorrect. And in option D, the sign of activation energy is positive, which will always be the case. Therefore, option D is the correct option for this question. Question 15. The formation of liquid water from hydrogen and oxygen may occur in three stages. Stage 1 has hydrogen gas and oxygen gas having their bonds broken, producing gaseous hydrogen atoms and gaseous oxygen atoms. So since bond breaking is involved, this process is endothermic. In stage 2, the gaseous atoms combine to form the molecule of steam. So since bond formation is involved, this stage is exothermic. And the third stage involves the conversion of steam to liquid. That means a change of state from gas to liquid requires energy to be released. Since energy is being released, this stage is also exothermic. The question asks, which stages would be exothermic? That would be stages 2 and 3, making option C the correct option for this question. Question 16. In 4 separate experiments, 1, 2, 3, and 4, nitric acid was added to excess marble chips and the volume of carbon dioxide formed was measured. In all 4 experiments, the same volume of nitric acid was used. Its concentration or temperature or both concentration and temperature were changed. The result of the experiments are shown on the graph. Okay, so now let's look at these results. So for experiments 1 and 2, more volume of carbon dioxide is produced compared to experiments 3 and 4, which means the concentration for experiments 1 and 2 was higher as compared to for 3 and 4. So the concentration for experiment 1 and 2 used for nitric acid is greater than the concentration for experiment 3 and 4, resulting in more of CO2 being produced as compared to experiments 3 and 4. Okay, the next thing. Experiments 2 and 4 produce the same volume of carbon dioxide as experiments 1 and 3 respectively. However, they take place over a long period of time. That means the same quantity of CO2 is produced, but it takes longer for it to be produced. The reason could be that the temperature at experiment 2 and 4 would be lower than those at experiments 1 and 3. That is why it would take longer for the same volume of carbon dioxide to be produced. So temperature is lower for experiments 2 and 4 compared to 1 and 3. Okay, which statement is correct? A lower concentration of acid was used in experiment 3 than in experiment 1. Yes, this is correct. Experiment 4 was faster than experiment 3. No, experiment 3 was faster than experiment 4. The acid used in experiment 2 was of a lower concentration than in experiment 1. No, the concentration of acid used in both experiments 1 and 2 was the same. And the temperature of the acid was the same in experiments 1 and 2. No, experiment 2 was carried out at a lower temperature than experiment 1. Therefore, the correct option for this question is option A. Question 17. The equation shows the formation of sulfur trioxide in the contact process. What would decrease the yield of sulfur trioxide? So in order to decrease the yield of sulfur trioxide, the backward reaction needs to be favored. So let's look at the conditions provided. Addition of more oxygen. If we increase the concentration of the reactants, the forward reaction would be favored in order to maintain the original concentration of the reactants. An increase in pressure. An increase in pressure favors the side with the lesser number of moles. There are 3 moles of reactants and 2 moles of products. When the pressure will be increased, the reaction will be favored in the forward direction. An increase in temperature. So an increase in temperature favors the endothermic side of the reaction. Here, the forward reaction is shown to be exothermic. So an increase in temperature will favor the backward reaction, which would be the endothermic side. And removal of sulfur dioxide from the reaction chamber would cause the concentration of products to decrease. The equilibrium will be favored in the forward direction in order to adjust the concentration of the products. Therefore, the only option with the backward reaction being favored is an increase in temperature, making C the correct option for this question. Question 18. Zinc reacts with dilute sulfuric acid. From this equation, what can be deduced about the reaction? It is a redox reaction. So let's check. Zinc has an oxidation state of 0 in the reactants and it has an oxidation state of +2 in the product. So from 0 to +2 is oxidation. While H2SO4 has H positive ions with a charge of +1, and on the product side in the hydrogen gas the oxidation state of hydrogen is 0. So +1 to 0 is reduction. Therefore, both reduction and oxidation are taking place in this reaction, making it a redox reaction. It is exothermic. Okay, so metal reacting with acid is an exothermic reaction, but it is not possible to predict whether the reaction is endothermic or exothermic just by looking at the given equation. So this option cannot be predicted. Next, zinc is acting as a base. No, zinc will act as a base if it accepts H positive ions. It is not accepting any H positive ions. And zinc is acting as a catalyst. Zinc is taking part in the reaction and is being converted into zinc 2 positive ions. It is not being regenerated at the end of the reaction. So its role as a catalyst is not established in this equation. In fact, its role as a reactant is established in this equation. So as a result, the correct option for this question is option A. Question 19. Consider the 3 reactions. Reaction between ammonium chloride and calcium chloride. Now, ammonium chloride is an acidic salt and calcium hydroxide is a base. So, a reaction between an acidic salt and a base would result in the formation of ammonia. It would result in the formation of calcium chloride and it would result in the formation of water. Next, ethane burning in air. A hydrocarbon burning in air produces carbon dioxide and water. And 3, reaction between ethanoic acid and ethanol would produce an ester and water. So the products of each reaction have been shown here. Okay, what is true for all 3 reactions? Carbon dioxide is formed. Carbon dioxide is only formed in reaction 2, not in 1 and 3. Neutralization takes place. Neutralization is taking place only in reaction 1, not in 2 and 3. Oxidation takes place. Oxidation is only taking place in reaction 2, not in 1 and 3. Water is formed. So, water is formed in reaction 1, water is formed in reaction 2, and water is formed in reaction 3. So, this statement is correct, that water is formed in all 3 reactions, making option D the correct option for this question. Question 20. Which statement about weak acids is correct? They are partially ionized? Yes. The definition of a weak acid is that weak acids are partially ionized in aqueous solution. So A is basically the definition of a weak acid. B, They do not react with metals. All acids react with metals. C, they do not react with strong alkalis. All acids react with alkalis. They, D, their solution have pH values in the range of 0 to 2. Now, this range is for strong acids, not weak acids. So, this is incorrect. They have a range of somewhere between 3 to 6. 0 to 3 is the pH range of strong acids. Therefore, the correct option for this question is option A.